Okay, this video is about solving multi-step equations, also known as complex equations. They're equations that are going to take a lot more, or maybe just a couple more steps than a two-step equation would to solve. Here we have an example of a complex equation. We've got parentheses, we've got fractions, we've got multiple parentheses, we've got the variable on both sides of the equation. And yet, this can still be solved. It just requires you to take more than the normal 2 or 3 steps to solve. Now, there are many different ways of attacking this problem. You don't have to do it in any particular order, but I have come up with the following order of solving that helps, from what I've learned, helps prevent students from running into errors, common errors, when actually solving these complex equations. My first step would be to multiply to get rid of fractions. Here we have a 3/5 and a 1/2. I'd be multiplying by a common multiple of the denominators, which in this case would be 10. And when you do that, it's going to end up getting rid of the fractions in the whole problem. Step 2 would be to distribute, to get rid of parentheses. Whatever the resulting here, I would distribute. Whatever resulting here, I distribute. Distribute this to get rid of the parentheses. And then I would combine like terms. And by this I mean on the same side of the equal sign. I've got an x term here, an x term here. I'm going to end up combining those once I've gotten rid of the parentheses. And then there's an x term here, and there's a bunch of constants it looks like over here, so I might end up having to combine some constants over here, as well as over here. Right, but the next step would be to combine those like terms. Then I would move the variables to one side of the equation. As you can see, we've got x over here, we've got x over here. After combining the like terms, there will only be one term with an x over here and one term with an x over here. Well, I would move it to one side. Now, when you move the variables to one side, that is kind of like combining like terms, but since you're combining across that equal sign there, you have to work with opposite operations to get it there. Then you would end up having a 1 or 2 step equation. After you've done these steps, you will most likely end up with a 1 or 2 step equation. If you didn't, chances are you've made a mistake. All right, let's take a look about some examples here, some simpler examples in this one. Okay, here's an example of an equation that has variables on both sides. First thing I would do is I'm going to draw what I like to call the railroad tracks. It helps separate the two sides of the equation, and I know whenever I cross these railroad tracks, I'm going to have to use opposite operations to get the stuff to the other side. All right, now, according to my 5 steps, there are no fractions, there are no parentheses, so I can skip those first 2. The third step would be to combine like terms. These are not like terms, these are not like terms. So I'd proceed straight to that 4th step, which says to move the variables to one side. Now here I've got a 3x and a 5x. I need to either move the 5x to this side or the 3x to that side. I generally like to move the smaller one towards the larger one. To do that, I have to think in terms of what this 3x is doing to this side of the equation. Although it's not written here, it is being added to this side of the equation. So to get to the other side, I would add the opposite. I would end up subtracting 3x from both sides. 3x and negative 3x, they would cancel. You'd have negative 5 is equal to 5 minus 3 is going to be 2x plus the 9 is still going to be there. Now at this point I have a 2-step equation. Got to get rid of the 2, got to get rid of the 9. Those are my 2 steps. First, take care of the 9 by doing the opposite order of operations. Instead of adding, I'm going to subtract 9. That's going to give me negative 14 is equal to 2x. Instead of multiplying by 2, I'm now going to divide both sides by 2, which is going to give me negative 7 is equal to x. Does it matter that x is on this side of the equal sign instead of this one? No. That is still our solution. X is equal to -7. And we could always double check it by plugging it back into the original. 3 times -7 is going to be -21. Minus 5 is going to result in -26. On this side, we'd have 5 times -7, which would be -35, plus the 9 would give me -26. So it does double check that way. Now, when you have variables on both sides, some interesting things will happen. Sometimes the variables will drop out. Let's see what happens with this one. First, I'm going to draw my railroad tracks. This one does have like terms here. There's no parentheses, no fractions, but there are these two like terms, 3x and 2x. So I'm going to combine those like terms. This stays the same. This becomes 5x plus 8. The 2x and the 3x become 5x. That's my combining like terms. All right, then I would move the variables to one side by subtracting 5x from both sides. It's going to cancel here and it's going to cancel here. I end up with 7 is equal to 8. Is 7 equal to 8? Never. Turns out no matter what value I'm going to plug in for this x value here, whether it be here, 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 whatever value I plug in, I'm never going to get the two sides to be equal. So in this case, when the variables drop out and these things are not equal, you have what is known as no solution. No solution. There is no solution to this equation. And that can happen when you have the variable on both sides like this. Now, it is possible for the variables to drop out and still have a solution. If, for some odd reason, we were to change this number to an 8, when I did do the subtract 5x from both sides, I'd end up with 8 equals 8. In this case, it would not be no solution, since no matter what I plug in for x, I would still get both sides being equal. This would be infinitely many solutions. Because no matter what value I plug in for x, I would still get 8 equals 8. And that would mean that when I get 8 equals 8, whether I put in a billion for x or -2 for x, I'd always end up with 8 equals 8, which means there would never be anything that was not a solution. So when the variables drop out and the two sides are equal, you have infinitely many solutions. If they're not equal, then you would have no solution. Okay, there are going to be times when your equation is going to have parentheses. To get rid of parentheses, you're going to use the distributive property. To use the distributive property, we're going to multiply this times this outside number times everything inside of the parentheses. 3 times 2x gives you 6x. 3 times -4 is going to give you -12. So at this point, I have 6x minus 12 equals 3x plus 3. Now, again, I want to work with those railroad tracks there. Now I've got the variable on both sides, so I want to move them to one side. I like to move the smaller one towards the larger one. That's going to give me 3x minus 12 is equal to 3. Then I've got a two-step equation. I add 12 to get rid of the 12. I've got 3x is equal to 15. Then I would have to divide both sides. Let me rewrite it over here. Divide both sides by 3, and I get x is equal to 5. And there's my final answer. So distributing to get rid of parentheses and then solve from there. Is it possible to solve other ways? Yes, if you saw the fact that this 3 was a common factor in both of these terms, you could have divided both sides by 3 first and then solve from there. But it's not always going to be so easy. That's why I recommend using the distributor property to get rid of parentheses when you've got this situation. Okay, now we have come to the most dreaded word in the mathematical dictionary, fractions. No one likes fractions, but okay, let's see how we can work it. Now, if you want to, you can actually get rid of the fractions by multiplying whenever you multiply a fraction by its denominator or a multiple of its denominator, it becomes a whole number. So if you multiply an entire equation using that multiplication property of equality by a common multiple of all of the denominators, you will end up getting rid of all the fractions. In this case, we have a 4, a 2, and a 12. The least common multiple would be a 12. So I'm going to multiply everything by 12. When I do that, 12 times 3/4, I can do some cross simplifying here. 4 goes into 12 3 times. 3 times 3 would give me 9, so I have 9x. 12 times 1/2 is going to give me a 6. And 12 times 7/12 will result in 7. From here, it is now a two-step equation to solve. I add 6 to both sides. I get 9x is equal to 13. Divide both sides by 9. I get x is equal to 13 over 9, which would be 1 4/9. Since we did start this problem with fractions, we did have fractions to begin with, the answer should stay as a fraction. Do not convert this to the decimal. The decimal value would be 1.4 repeating, but again, since we started with fractions, your answers should remain in a fraction form. Mixed number preferably. Improper fractions are not really the best way to leave your fractions. Okay, now let's look at this dreaded problem from the beginning of our video. Alright, if I start off by multiplying by a common multiple of all the denominators, which would be 10, this would become 6 times x minus 2 plus 20 times x plus 3 equals 5, 3 minus 2x plus 10. Notice how I didn't multiply by the stuff inside of the parentheses here. When I multiply by the fraction in front here, it is multiplying this whole term. In a way, this is a term and this is a term. So I do have to do the 10 times this and the 10 times this, but not times the individual stuff inside of this set of parentheses. Alright, then I would distribute 6 times this, 6 times that. I get 6x minus 12. 20 times x, 20 times 3. I get 20x plus 60. 5 times 3, 5 times 2x, I get 15 minus 10x plus the 10. So that takes care of steps 1 and 2. Step 3 is to combine like terms. I have a 6x and a 20x here. Those would combine to give me 26x. Then I have a negative 12 and a positive 60, which would combine to give me a 48, and it's just a constant there. Then I have the 15 and 10 are going to give me a 25, and I still have that negative 10x. I combine this term with this term to get the 25. Now we need to move the variables to one side. To move them to one side, I have to, to move them one side, I'm going to have to move, I like to move the smaller towards the larger, so I'm going to add 10x to both sides, which is going to give me 36x plus 48 is equal to 25. Then I would solve the two-step equation, minus 48, I end up with 36x equals 73, no, I've got 20. That would be 23. Negative 23. Can't seem to get the negative sign there. Okay. And then I would divide both sides by 36, which is going to leave me with this bad fraction as my answer. But that is the final answer. X equals negative 23 over 36. That cannot be simplified any further. I hope this was helpful. Thank you.